Welcome to American Northwest Aviation. I'm Danny. Today we're going to look at the ACS, the Airmen Certification Standards document from FAA.GOV. So once you get there, you'll click on this option here, the airline transport pilot and type rating for airplane category. That'll bring us to here. You should be familiar with this by now. This replaced the PTS about 7 years ago. And the purpose of this lesson is to determine what's the earliest point on the runway we can touch down and what is the latest point on the runway that we can touch down, and to just become familiar with the Airmen Certification Standards document. So we'll scroll down from the previous page to the table of contents. We're interested in the area of operation 3, takeoffs and landings. And we're concerned with task B, which is normal approach and landing. By the way, if you haven't become familiar with the document and how it's laid out, it's much more detailed than the PTS was. I may be dating myself mentioning the PTS at this point. So we're going to go to page 19 and we'll find ourselves on page 20 as well. And we'll just scroll down. But I've got it preloaded here. So area of operation 3, takeoffs and landings. And we'll scroll down to S10, which is on page 20. And we want to touch down with the runway center line between the main landing gear at the appropriate speed and pitch attitude at the runway aiming point markers minus 250 feet to plus 500 feet, or where there are no runway markings, 750 to 1500 feet from the approach threshold of the runway for airplane single-engine land and airplane multi-engine land ratings. And just notice that in this section they also have airplane single-engine C and airplane multi-engine C references. So some of these sections or items are not relevant to airplane multi-engine land or airplane single-engine land. From here, we're going to go ahead and look at AIM, Airman's Information Manual, Section 3, Airport Marking Aids and Signs. And we can see a precision instrument runway markings. So from the very beginning of the threshold to the first fixed distance markers, that's 500 feet. And then to the next markers, which in this case is the aiming point markers, that's 500 feet. And then it's 500 feet to the next fixed distance markers to the beginning. So to apply that 750 foot zone that we can land in, which was minus 250 to plus 500, that's going to be from halfway between here and here, which would be about here if that was continuous, to 500 feet after this point, which would be right here. Now I've taken the trouble to make a chart or a diagram based on the runway at SeaTac in Seattle. Precision runway 16 center at SeaTac. Excuse the faded marks, but using a real runway gives us a few clues as to what is really going on out there. And that is that most of the traffic is landing within the area that we're saying you need to land in. I shouldn't say that, because if you look down here, they've gotten into the no-no land. So I've marked this out in red to show 500 feet before the aiming point markers. So this is 500 feet, and that's the only cue we have when we're coming in for a landing. We can see the beginning here, we can see the beginning of the aiming point markers, and we have to estimate halfway so that we know that this is 250 feet before the aiming point markers, and then 500 feet after is just before the next fixed distance markers, giving us a total of 750 feet where we can actually touch down. I've marked it up additionally to make it real clear. You might want to pause this and take a screenshot of it unless you already have this. So just to reiterate, we have 500 feet from here to here. We estimate halfway back to get our 250 feet before. And we have another 500 feet from the beginning of the from the aiming point markers to the just before the beginning of the fixed distance markers, giving us a total of 750 feet, which I've marked in the yellow rectangle here as the acceptable touchdown area in yellow rectangle. I don't want to call it the touchdown zone because that's defined differently as the first 3,000 feet of a non-precision runway and so on. I'm not going to define it here, but I'm not going to call it the touchdown zone, but it is my acceptable touchdown zone. So if we go back to the S10 here, just to see if our language is matching up with the diagram. Touchdown zone with the runway, touchdown with the runway center line between the main landing gear at the appropriate speed and pitch attitude at the runway aiming point markers minus 250 feet, which we showed that you have to estimate, plus 500 feet, which is very clear. You'd want to touch down before those next set of fixed distance markers. Or where there are no runway markings, 750 feet to 1,500 feet from the approach threshold of the runway. Let's take a look at that. So let's assume this is a non-precision runway now. We don't have these markings here or these markings, and we might not even have threshold markings. So all we have is the beginning of the runway, and we go 750 feet, which we know in this example, which you would not know on a non-precision runway. We know that 750 feet is going to be right here. So it's the same place that we're allowed to touch down on a non-precision runway as a precision runway. You just have to estimate it on a non-precision runway. So you have this 700 feet to not touch down. Treat it like a displaced threshold, I guess. And you can do your touchdown here all the way to here on a non-precision runway, but again, you're estimating. So there's no difference. It's just your only reference point is the beginning of the runway on many runways, and you just have to estimate where 750 feet is. So going back here, looking at some of the other skills that are listed, the applicant exhibits the skills to S1, coordinate with crew if applicable and complete the appropriate checklists. Make radio calls as appropriate. Maintain a ground track that ensures the desired traffic pattern flown takes into consideration obstructions and air traffic control or evaluator instructions. Evaluators or examiners, if I remember correctly, evaluators what they use in EASA, and examiners are with the FAA, or maybe the FAA is using evaluators now too as the term, but basically that's the guy running the sim, or the fourth guy in the sim that's with the FAA, or he's designated to evaluate you and pass or fail you on your check ride. Duh, huh? Anyway, ensure the airplane is aligned with the correct assigned runway or landing surface. And how do we do that? Of course, we look at our mag compass or our directional gyros. Scan the runway or landing surface and adjoining area for traffic and obstructions. Select a suitable touchdown point considering wind, landing surface, and obstructions, and of course, S10 here. Establish the recommended approach and landing configuration and airspeed plus or minus 5 knots, and adjust pitch attitude and power as required to maintain and stabilize approach. Maintain directional control and appropriate crosswind correction throughout the approach and landing. Make smooth, timely, and correct control application before, during, and after touchdown. Of course, if it's turbulent, it might not be so smooth. You might have to be more aggressive. We already read S10. S11, during round out and touchdown, contact the water. Okay, that is one of the airplane's single engine, seaplane, and so on phrases. Skip 11. S12, decelerate to taxi speed 20 knots or less on pavement, on dry pavement, 10 knots or less on contaminated pavement. So with rain, I'd say more than a quarter inch, and snow, that's usually defined in the manufacturer's manual as to what's considered contaminated, if I recall correctly. And to within the calculated landing distance, plus 25% for the actual conditions with the runway center line between the main landing gear. At least one landing, airplane single engine land, airplane multi-engine land. S13, use spoilers, prop reverse, thrust reverse, wheel brakes, and other drag braking devices as appropriate to safely slow the airplane at least one landing to a full stop. Execute a timely go-around if the approach cannot be made within the tolerances specified above, or for any other condition that may result in an unsafe approach or landing. And finally, use runway incursion avoidance procedures if applicable. That's all we have for today. Please subscribe, and please click on the notification bell, comment on where you're watching from, and what kind of videos you'd like to see, and share this video. Thank you.